Hey everyone, Mr. Skelton here. We are back at it for lesson 4 in unit 4, and today we're going to be talking about long division within polynomials. Alright, and so this first problem that we have here, number 1, we're actually going to skip this. This is a problem that we'll come back to. It's actually not a division problem. I kind of put it in here for a review. If you want to give it a try, you can, but it's a solving problem that would require you to use your graphing calculator, and it's a problem that was like very close to one that was in number 3. So we're going to go ahead and jump over and skip over to the second slide. And we're going to talk about long division. Now, I'm going to start off with a problem that, just to refresh your memory a little bit, I'm going to take 3,540 and we're going to divide it by 15 using long division. So you kind of have to go back a ways. I can't remember when they teach this skill, but you're using division. If you have a 2-digit number, you look at the first 2 digits of the problem and you say, okay, how many times is 15 going to 35? You would say twice, right? And 2 times 15, you multiply these together to get 30, and then you subtract them, and you would get a 5, right? And then you pull the next number down. I always used to draw arrows, so I'd bring the 4 down. And then you ask the same question. 15 goes into 54, how many times roughly? You'd probably put 3, right? Because 15 times 3 is going to be 45. And so you would subtract those and get a 9. And then you would bring down your last digit right here. And you have 15 going into 90. So that's going to be what, let's see, 15 and 15 is 30. 69, so that's going to be 6. And 6 times 15 is 90. So you subtract those and you get a remainder of 0. So when you get a remainder of 0, you know that your answer is good and there's no remainder, so it's 236. Okay? All right, so that's the concept that we're going to apply today. So the concept of long division is going to be carried over into these problems. So let's start with the first one here. It says find all 3 solutions. So what that kind of means to me is we're going to find solutions. Somehow we got to get this into factored form eventually so that we can produce zeros, right? So in this problem, it tells you one of the solutions is 7. So in my mind, I always think of it like this. If I know one of the solutions is 7, go back a step. What would be a factor? If you go backwards, what would be the factor of this solution? That would be x minus 7, right? That would be our factor before we got to x equaling 7. Like if you set this equal to 0, you get x equals 7. The reason that's important is because we need to use this x minus 7 as a factor to use long division within this problem. So this is what it looks like. We're going to go x minus 7, and then we're going to put the x to the 3rd minus the 2x minus 13x plus 140. Now, one thing to keep in mind that you want to check for before you start. You have to make sure that you have an x third, or that whatever the highest degree is. It could be a 4, it could be a 5, but they have to go in order. And if you have a missing number, then you have to put a 0x whatever in for it. Okay? So like on this one, we have x to the 3rd, x squared, a single x, and then a constant. So we're good to go. I'm going to flip over to you can see this problem right here. This is the very last problem. This goes x5, x4. There's no x to the 3. So when I go to write this problem out, I know I'm kind of jumping ahead, but I want to show you because this is important before you can start. You would put in a plus 0x to the 3rd. You have an x squared, so plus 9x squared. There's no x either, so we plug in another 0x and then the minus 11. Okay? The 3x plus 1 would come out in front. So that's how you, before you start, you have to make sure that, 1, that they're in order, 2, that if you have any missing degrees, you have to plug in a plus 0x cubed, all right? Or whatever the missing degree is. Okay, so what we do when we do long division is we just take this x, and just like we did up here, we asked, how many times is 15 going to 35? We said 2. We're going to kind of repeat that same concept. So we'd say, okay, how many times does x go into x to the 3rd? Or what times x gives you x to the 3rd? We would say x squared, right? And then what we do is, just like we did here, we went 2 times 15 and got 30. We're going to go x squared times x, which is x to the third. But we have this minus 7 here as well, okay? Oops, I wrote something down wrong here. That's supposed to be an 8x squared. There we go. X squared times x is x cubed. X squared times a negative 7 is a minus 7x squared. Now, what I always do is I always put this in parentheses, and remember, you're subtracting, just like I subtracted this 30 here from the original problem that we did. I always subtract this, and then I run it through. So this is going to be a negative x squared. A negative times a negative 7x would be a positive 7x squared. And then I add my terms together. So my x3's cancel out. I get a negative 8x squared and a 7x squared, so that's a minus x squared. And then what do? We pull down our next term, which is a negative 13x. And we just repeat this over and over. What times x will give you negative x squared? That'd be a negative x. Negative x times x is negative x squared. Negative x times a negative 7 is a positive 7x. Okay? But again, I always put it in parentheses, run the minus sign through, so that would turn that into a plus. That would turn that into a negative, and then I add them. So my x squareds cancel out, and I have negative 20x. And bring down your next term, which is the 140. What times x gives you negative 20x? It'd be a minus 20. So negative 20 times x is negative 20x. Negative 20 and negative 7 make a positive 140. And then again, I put in parentheses, put the negative out front, and then run it through, so that becomes a positive, that becomes a negative, and then I add them, so cancels, and I get a remainder of 0 because there's nothing else to pull down, okay? Now, it really works out nice when you get a remainder of 0, because now we know that x squared minus x minus 20 is another factor. So when it says find all 3 solutions, here's how this would work. We know that x minus 7 is a factor. We know that x squared minus x minus 20 is a factor, but we always want to look, we're finding solutions, right? So we're actually setting this equal to 0. That's important to know. So you got to look to see if you can factor this, which you can. This becomes x minus 5 and x plus 4. This is still the x minus 7 out in front. So I factored that trinomial, set it equal to 0. So my 3 answers, you set each of these equal to 0 and solve. So I get x equals 7, x equals 5, and x equals negative 4. Those would be your 3 solutions. Okay? All right, let's go on to the next one. So you just do the same thing over and over again here. Always check the problem, x4, x3, x2, x, and then a constant, so we're good. So it's 2x minus 3. And then we're going to write this in. And then we just repeat the process. What times 2x gives you 2x to the 4th? That would be just x to the 3rd, right? X to the 3rd times 2x, or 2x would be 2x to the 4th. X to the 3rd times a minus 3 would be a negative 3x cubed. Run the minus sign through, turns that into a positive. Add them, cancels, negative 6x to the 3rd. Bring down your next term, minus 13x squared. What times 2x gives you negative 6x cubed? That'd be a minus 3x squared. So that's minus 6x cubed. Negative 3x squared times a negative 3 would be a positive 9x squared. Minus sign, run it through, add, subtract, add them, cancels out. I get a negative, negative 22x squared. Okay. Bring down the 4x, positive 4x. What times 2x gives you negative 22x squared? That'd be a minus 11x. So I get a negative 22x squared plus 33x minus, run it through, make that a negative, add them. So I'm going to get that to cancel. I'm going to get a negative 29x. And then I bring down my negative 15. And now on this one, let's see if I did something wrong here. Negative 29x, 2x. Nope, looks like I'm okay here. So what happens is this, when you can't put the 2x into the negative 29x, that means you're going to have a remainder. So when I can't go in evenly, this becomes my remainder. So I have a remainder of negative 29x minus 15, and you just write it like that. So our answer would be this, with a remainder of negative 29x minus 15. All right, the last one we kind of talked about already, where we have our 6x to the 5. There's the degree of 4. We're missing the x to the third, so I put 0x third in there. I have an x squared. I don't have an x, so I put 0x and then minus the 11. So we just repeat this. So why don't you hit pause and try this one and then see what we come up with. Okay, what times 3x gives you 6x to the 5th? That would be a 2x to the 4th, right? 2 times 3 is 6, x4, and x is x to the 5th. 2x to the 4th times 1. Remember, you got times them by both, so that's going to be a positive 2x to the 4th. And look what happens on this one. When I run my negative sign through, that becomes a negative, that becomes a negative, and I add them. So those cancel out, and those cancel out. Okay? If you bring down your 0x to the third, if you were to bring this down, 0x to the third, what times 3x gives you 0x to the third? Nothing, right? So it's really not there in this problem. So we can skip down and go to the 9x squared. So what times 3x gives you 9x squared? That would just be a positive 3x. So I have 9x squared, and then plus 3x, so plus 3x, okay? If you brought down this 0x with it, because now I recognize that I have an x, so I brought down this plus 0x with it, that becomes a minus, that becomes a minus, and I add them. So I end up getting a negative 3x here, and then I bring down the negative 11. So I have what times 3x gives me a minus 3x? That'd be a negative 1. So I have negative 1 times 3x, which is a negative 3x, and negative 1 times positive 1, which is a negative 1. And then I'm going to run it through, so that becomes a positive, and then I add them, and then I get negative 10 as my remainder. So my answer would be 2x to the 4th plus 3x minus 1 with a remainder of negative 10. And when you have a remainder, that tells you that this 3x plus 1, it does not divide evenly into the polynomial, and therefore 3x plus 1 is not a factor of this. That's really important to understand, right? If you go back to our previous ones, when we had a remainder of 0, that tells you that x minus 7 is a factor of this polynomial, and thus that can be set equal to 0 to give you a 0 or a solution. The ones that have remainders are not factors, okay? This takes a little bit of time, and I know I only went through a couple here, so we'll go through some together in class just to make sure you feel good about it. It's a tedious process. There's a lot of room to make small mistakes, so if you have questions while you're working or you're not sure about a certain step within the video notes, I'd be more than happy to go through it with you in class when we have a bunch of time to do that, okay? All right, take care.